For any expecting parent, figuring out what's safe and what's not during pregnancy can be, well, it can be pretty stressful. So today, we're going to put on our detective hats and investigate a really important question. Are those common heartburn medications actually safe? Let's dive into this scientific detective story.
All right, so our whole case here starts with a worry that I'm sure hits close to home for millions of people. It's a question that really pits the need for relief against this deep-seated fear of the unknown.
And here it is, the central mystery we're here to solve. Could the very medicine you take for that really awful pregnancy-related heartburn, could it possibly harm your child's developing brain? I mean, that is a terrifying thought, and it's one that absolutely deserves a clear, evidence-based answer. Now, this fear didn't just pop up out of nowhere. As you can see from this timeline, the scientific community has been gathering clues for a little while. Back in 2022, a study flagged a potential issue in preterm infants. Then, another one suggested a higher risk for epilepsy. These earlier findings created a real sense of urgency, and really, they set the stage for the massive investigation we're looking at today, one that was designed to find a definitive answer. And that brings us to our main piece of evidence, this huge study out of South Korea, published in the very prestigious Journal of the American Medical Association. This thing was designed to crack this case once and for all. So let's just pause for a second and appreciate the scale we're talking about here. This study didn't just look at a few hundred people, or even a few thousand. No, it analyzed data from over 2.7 million children. That is an incredible amount of information, which gives this investigation some serious statistical power to find a really reliable answer. Okay, so the researchers started their investigation with a pretty standard, straightforward approach. They compared the children of mothers who took these acid suppressants to those who didn't. And of course, they statistically adjusted for all the obvious differences, things like the mother's age, her income, and her overall health before she was even pregnant. And right off the bat, the initial results, they looked pretty worrying. This first pass at the data showed a small but statistically significant increased risk for several disorders, including ADHD and autism spectrum disorder. The key numbers to look at here are these hazard ratios. Just think of it this way. A ratio of 1.0 means no change in risk at all. And as you can see, all of these numbers are just slightly above 1.0, which suggests there might be a real, if small, connection. So, at this stage in our investigation, it really looks like the evidence is pointing in one direction, right? The medication seems to be the culprit. But in any good detective story, and definitely in any good science, you can't just stop at the first clue. You have to look deeper for hidden details. You have to ask, is there another suspect we haven't considered yet? And this, right here, is where our story takes a crucial turn. This is where the real detective work begins. The investigators started to wonder, what if there's a hidden suspect? Something else entirely that could explain these initial results. And that brings us to a really critical concept in any scientific investigation, the confounding factor. It sounds technical, but it's basically a hidden variable that's connected to both things you're studying. In our case, the medication and the health outcome. It can create this illusion of a direct link that isn't actually there at all. To make this crystal clear, let's use the classic example. You've probably heard this one. Data shows that when ice cream sales go up, so do shark attacks. But does eating ice cream make sharks want to bite you? Of course not. The confounding factor, the real hidden culprit, is summer heat. Hot weather makes more people buy ice cream, and it makes more people go swimming in the ocean. Okay, so let's apply this to our case. On the surface, it looked like the medication was leading to a higher risk for these disorders. But the researchers asked, what if there's a confounder here? What if there are shared family traits, things like genetics or lifestyle or environment, that are responsible for both the mom's need for the medication in the first place and the child's underlying risk for a disorder? That is the hidden suspect we need to investigate. So, to unmask this hidden suspect and finally solve the mystery, the researchers needed a much more powerful investigative tool. And they found one. It was a brilliantly clever method called the sibling test. The real beauty of this test is that it's specifically designed to get rid of all those confusing family factors. By comparing siblings from the same family, the scientists could basically isolate the drug's effect from all that other background noise. So, here's how it works. It's really genius in its simplicity. First, you find families that have at least 2 kids. Then, you look for cases where the mom took an acid suppressant during one pregnancy, but she did not take it during the pregnancy with that child's brother or sister. See where this is going? By comparing those two siblings, you automatically control for all the stuff they share: their genes, their home environment, their parents' habits, all of it. The main difference between them is the exposure to the medication. This sibling test was it. This was the final, definitive piece of the puzzle. It was time for the researchers to reveal their findings and close this case for good. And here it is, the big reveal. Just look at this table. When the researchers compared the siblings, the link completely vanished. Gone. The risk for every single one of these disorders, ADHD, autism, all of them, is now statistically non-existent. See how all those hazard ratios are hovering right around 1.0? That's the statistical way of saying there is no difference in risk. The scary connection has disappeared. So the verdict is in. That apparent link between these medications and all these disorders, it was an illusion. It was a classic case of a confounding factor misleading that first analysis. The real culprit wasn't the medication at all. It was those complex, shared family factors that the first, simpler analysis just couldn't see. So what should we take away from this whole investigation? Well, first, and this is maybe the most important lesson in all of science, correlation does not equal causation. Just because two things happen together doesn't mean one caused the other. It also shows us how a single analysis can be really misleading, and why a clever study design like this sibling comparison is absolutely crucial for finding the real truth. It all comes down to asking that one simple question: could something else be causing this? And that really brings us to our final thought. This explainer wasn't just about one medication. It was about how to think like a scientist, how to be your own detective. So the next time you see a scary health headline, what's the first question you're going to ask about the study behind it?